All right, guys, so we're going to We're going to derive the second equation of kinematics. The second equation of kinematics is going to find your total displacement. And the second equation of kinematics is your displacement is equal to 1/2 your final velocity minus your initial velocity times a change in time. But how do we get that? Where does that come from? So let's derive it. We have a generic velocity time graph. So again, I just want to draw a generic velocity time graph. All right. And I'm going to randomly pick some points here. All right, so there's my velocity time graph. It's generic. There's no units. I have a line for a constant acceleration. So I have a constant acceleration here. And I need to label points on the graph. So I'm going to label my initial time and my initial velocity. And I'm going to pick this point right here because that looks good to me. And I'm going to label that my final time and my final velocity. All right, and now I need to find displacement. And we learned when we looked at velocity time graphs that when we're trying to figure out displacement, we are looking at the amount of area underneath the graph. So if we're looking for the total displacement here, we need to find the area of this space. So I need to divide it into two chunks. I have the area 1 and area 2. And from our notes, we know that our change in displacement, or our displacement, is equal to area 1 plus area 2. So area under graph gives displacement. All right. So then I can sub in the formulas I would use to find the area for 1. So I have my displacement equal to, for the area of this first one, all I have to say is length times width. For the area of my second one, I have 1/2 base times height. All right, so let's keep going. Change, or my displacement is my length on area 1 is my final time minus my initial time. All right. And I'm going to call this my initial velocity. That whole side is my initial velocity. So I'm going to multiply that times my initial velocity. All right, then I have plus 1/2 times the base of area of triangle 2 is my final time minus my initial time. My height. So my height for triangle 2. I have my final velocity up here. So I have my final velocity. But it's more than just my final velocity. My final velocity includes all this. I need to take out this chunk. So it's my final velocity minus my initial velocity. So I'm going to plug that in here. And now all I have to do is simplify. So my displacement is equal to a change in time times velocity initial plus 1/2 a change in time times velocity final minus velocity initial. All right, so now I'm going to have my displacement is equal to a change in time, V1, plus I'm going to distribute 1/2 V2 change in time minus 1/2 V1 change in time. All right, so I have change in time velocity 1 twice. So I can combine these two terms. So I'm going to get change or displacement is equal to 1/2. We're subtracting here. Final velocity change in time plus 1/2 initial velocity change in time I'm going to factor out 1/2. So I'm going to get velocity 2 change in time plus velocity 1 change in time. I can also factor out that change in time to the back end to make it look pretty. So I have displacement is equal to 1/2 my final velocity minus my initial velocity times our change in time. And there you have it. There's the second equation of kinematics.